Yeah, welcome everybody. My name's Scott, and today I'm going to talk to you about GraphQL. And admittedly, I did not come up with this catchy title name, and I'm sure it might have triggered a few people as well. But today we're going to talk about GraphQL and how it differs a little bit from REST. So I have posted these slides up on my blog. It's just my first and last name, scottsauber.com, and you can follow me on Twitter at scottsauber there as well. So I really have two goals that I hope you get out of this talk is hopefully just give you a brief introduction into GraphQL because I only have 10 minutes and this is like a week-long topic. But I also really want to spark some curiosity, hopefully, and get you looking at GraphQL the next time you have a new API to write, rather than maybe just defaulting to always picking REST. So who am I? I'm the director of engineering at a software consulting company based in the US, like in the center of the US in Des Moines, Iowa, called Lean Techniques. I'm the co-organizer of another user group, another .NET user group. And I blog as well. And I've used, relevant to this topic, I've used GraphQL at places ranging from startups all the way up to Fortune 100 large organizations. All right, so what are we going to talk about? We're going to talk about what's wrong with REST, like why would you even consider GraphQL? What is GraphQL? I'll do a live demo of GraphQL as well. And then we'll talk about the benefits that we saw in that demo. And we'll also talk a little bit about how GraphQL works. So what are the problems that I personally have seen with REST? Well, with REST, usually we're focusing on nouns. We have things like orders and customers and users and things of that nature, right? So like, why is that a problem? Well, if you're building a web application, and let's say you want to get a customer's first name, for instance, right? You might hit a customer endpoint, and more than likely, most REST APIs don't support the concept of sparse field sets, where you want to say, hey, I only want to get the first name. So normally you're getting like first name, last name, middle name, their address, like all that kind of stuff. You're getting way too much data than you actually cared about. As well as oftentimes you end up with this underfetching problem, which is the reverse problem, right? So I'm sure many of us have used things like Facebook, Instagram, whatever the kids are using these days, where you make a post, right? You post a picture, whatever it is, and then you have comments, right? So like with REST, you might have a REST endpoint that's like /comments, for instance, to get all the comments, but then you probably want to show like the first and last name of the person who left the comment. So you might have to like get all the comments back, get the like author ID of whoever created the comment, and then round trip to like a user's endpoint or something like that to get the first and last name of the people who left those comments. So that's an example of underfetching. The other problem with REST is like ultimately every REST API is a little bit different because ultimately it's not really a spec, right? Like nobody tells you exactly what HTTP methods you need to use, how your responses look. Like, do you put them under a data property or do you just return the data back? Like what status codes do you use and when do you use them? And like the other thing is, I don't know how many times I've had conversations with people about like, are we going to use a patch or a put, or, what status code are we going to return? And ultimately all that stuff really isn't value add to our end users, right? Like our users don't really care at the end of the day, most of the time, unless we're building APIs for consumption, which can be the case. But most of the time, like that's not actually really value add. Like ultimately it doesn't really matter at the end of the day. And the other problem I've seen with REST, and admittedly, this is not really a problem with REST, but more people's interpretation, is there's a lot of two-phase commits that I see where, let's say you're on Amazon.com and you're hitting place order, right? I see sometimes people have like an orders endpoint that they make a post to create the order, and then they loop over all the order details and hit an order details endpoint, right? Well, like that's fine and good up until, something happens in the middle. So let's say you have 3 order details, the first 2 succeed and the third one fails. Like, what do you do? Because there's really you're in a distributed transaction problem and there's no guarantee that you can roll the whole thing back. So admittedly, that's more of a boundaries thing. There's talk earlier about microservices. So this can also be a problem with microservices when you don't draw the right boundaries. So those are just some problems that I see with REST. So let's talk about GraphQL here real quick. So what is GraphQL? So GraphQL was an API spec that was created by Facebook in 2012 and then released to the public in 2015. And that spec provides a way for you to query your APIs and get the data at them. And we'll take a look at that here in a second. But really, a big part of that is the type system. So even if you're doing a Node GraphQL API using something like Apollo, where JavaScript doesn't have is not a statically typed languages, you still have to provide the types and say, hey, my response object looks like this, and it's got these properties, like this one's a string and that kind of thing. So even if you're in a language that isn't statically typed, you still have to provide those types to GraphQL, which then aids in discoverability. And we'll take a look at that here in a second. And part of the spec also gives you real-time subscription, so you can get like real-time updates with WebSockets. And GraphQL tries to model each request as either a query or a mutation. So a query being reading data, mutation being writing data. So create, update, delete. So if you're familiar with the CQRS pattern, command query responsibility segregation pattern, if you use things like mediator, that concept will be very familiar with you or to you. All right, so let's do a quick live demo here. So this is going to be using Hot Chocolate, which is a NuGet package in the .NET ecosystem. It's for spinning up a GraphQL server. You can also use, there's like GraphQL.net, things like that, but I'm going to be using Hot Chocolate. So one thing Hot Chocolate gives you out of the box is it's kind of like Swagger, where you can interact with your API. So I just have some this API in particular is just dealing with blog posts. So I've got two queries here called all blog posts and blog post. And you can see over here, so if I zoom in on that here real quick, you can see there's like a square bracket blog post there. So that's saying this returns a blog post array. And then the bang, the exclamation point there is saying, hey, this can't be null. So if I say I want all my blog posts, then I can start querying this and say like, hey, what are the different properties that I can look at here? So let's say I just want to get the title, and I can go ahead and run that. And I guess before we look at the response, let's just look at the request a little bit more here. So so the request that we're building up kind of looks like JSON, right? So we're saying, hey, this is the query I want to run, and then these are the properties that I care about. But we only really get the keys of it. We don't really get the values. And then if you look over here on the right-hand side, you notice everything's under a data key, and then my query that I'm hitting, and then it fills the response with the exact data that I asked for. So if I come over here again, and let's say I want the ID as well, and go ahead and run that, we can also get back the ID, but you can also do like more complex object graphs. So if I want to get the author's name, for instance, and I'll go ahead and run that, you notice now I'm getting not only the properties of the blog, but I'm also getting the author information here as well. So this is just showing you really briefly, since I only have 10 minutes of like interacting with a GraphQL API. But then you can do a similar thing for mutations as well. You would just have to put mutation at the front here, and then make your mutation query at that point. But if I go over here to schema reference, you can start seeing like all the different queries that I have. So in this case, I just have these two. As it says, hey, this blog post one takes in an ID. And I can drill in, okay, like what is a blog post? What is an author, and navigate through this whole system, because again, I've got those static types that are defined in my GraphQL schema to describe my API responses. All right, that was a quick tour through GraphQL. But let's talk about kind of what we saw there. So GraphQL helps solve the under and overfetching problem, because as you saw, I was just requesting the exact data that I wanted, and I didn't have to make multiple requests, right? So a single request got me back all of my data in a single response. And you saw a little bit around the free documentation that we got from the type system. And the documentation, because of that, is like forced to stay in sync, unlike things like Swagger, because with Swagger, oftentimes you have to provide like, data annotation hints of like what status codes it can return and stuff like that. And technically you can lie to Swagger, whereas in GraphQL, things are more tightly coupled. So you can't really stay out of sync. And the thing I interacted with there, it's called different things depending on what library you're using. So in hot chocolate, it's called banana cake pop. So they call everything after food. And in Node land, if you're using something like Apollo, it would be called GraphQL Playground. So that was that interactive tool for making queries and whatnot. So how does it work? A little bit under the hood. So unlike REST, you have a single endpoint with GraphQL. And everything you send it is a post. So that query that I showed you earlier, where I was building up the different pieces that I wanted to return, all that goes into a post. And you define the different queries and mutations, so you get to decide what data you're exposing to your users. And then under the hood, there's this concept called resolvers, where basically what a resolver is just like how you access the data, right? So for instance, in the example we had blogs and authors, right? So maybe we get blogs from this database over here, but we get authors from a whole separate API over there. So you can have resolvers at the field level. So you can say, hey, this part of the graph comes from this data source over here. So you can have different resolvers at different levels. So in summary, hopefully I outlined some of the problems inherent with REST and how GraphQL solves some of those problems. And hopefully it gives you a little bit of intrigue to evaluate GraphQL in the future, because I would say all of our clients that we have, they're either using GraphQL today or they're strongly evaluating it, like it's in the conversation. I don't know of a single client that we have that GraphQL isn't at least in the conversation. And that's not just because of me promoting it. Like I don't go to all of our clients, but it's something that I feel like is really starting to take off in our industry. So that's all I have.